More than 20 billion kilometers from the Earth, two lone spacecraft are exploring the universe. Launched by NASA way back in 1977, Voyager 1 and Voyager 2 were sent out to study the outer planets of the solar system. After completing their primary missions, both these spacecraft kept going. Today, Voyager 1 has become the farthest spacecraft from Earth. It is so distant that even signals from Earth take 21 hours to get there. But have you ever wondered how is NASA still in contact with these spacecraft? Most people struggle to get signals on their cell phones in remote locations. Then how does NASA contact these spacecraft that are billions of kilometers away? In the second episode of Ever Wondered, let us learn how we are still in contact with the two Voyager spacecraft. Well, the answer to this intriguing question relies on several factors. When it comes to sending or receiving signals, three elements play a significant role: the distance between the sender and the receiver, the time taken by the signal to travel across the distance, and finally, its attenuation or depletion. The farther a spacecraft, the harder it is to contact it. And since the signals travel at the speed of light, which is finite, reaching a faraway spacecraft requires more time and energy than the one that is near. Like a telephonic conversation with a friend, communication with a spacecraft is also a two-way process. There's a sender's end where an electromagnetic signal originates, and then there's a receiver's end, where the signal is eventually captured and decoded. At its point of origin, the signal spreads out in a spherical shape. Now here's the critical point. When we send out a signal, there is a high probability that background noise would interfere with it. The signal needs to cross a certain threshold to rise above the background noise, and to become easily detectable. This implies that the receiving end must be strong enough to detect even weak signals. Since the spacecraft are billions of miles away and half a century old, we cannot upgrade their technology. But we can improve the technology required to send and receive electromagnetic signals, which is exactly what NASA is doing. NASA has built the Deep Space Network, or the DSN, to communicate with several spacecraft in deep space. The network is a collection of radio antennae, designed to communicate with humanity's most distant spacecraft. It acquires data collected by a spacecraft, and then processes and decodes it to distribute it to various research projects. Its command systems allow it to remotely control the spacecraft's course and activities, while tracking it by the DSN tracking system. The three main facilities of DSN are situated at an equal distance from each other in Goldstone, Madrid, and Canberra. This positioning separates the complexes by about 120 degrees each in longitude, further allowing them to be in constant communication with spacecraft, even as our planet rotates. Since these three facilities are spaced roughly equidistant around the globe, for almost any location that you can imagine putting a spacecraft, there will always be a site for picking up their signals to maintain communications. While all these three facilities can still contact the Voyager 1 spacecraft, Voyager 2 can only carry on communications with the facility located in Canberra, Australia. In March 2020, the dish in Australia, including the radio transmitter used to contact Voyager 2, was shut down for an upgrade. The dish featuring the world-class radio antenna was built in 1972, and hadn't been upgraded since then. Because of that upgrade, Voyager 2 witnessed a radio silence for 7 months. After the upgrades, NASA sent a series of test commands to Voyager 2 in October 2020. The spacecraft successfully reverted after a few hours, thereby indicating that the communication is back on track. The Deep Space Network is used not only to send commands to the Voyager spacecraft but also several other space missions. They include the Perseverance and Curiosity rovers on Mars, the Juno spacecraft orbiting Jupiter, the New Horizons probe that has now crossed Pluto's orbit, India's Chandrayaan-2, and Mangalyaan, among many others. The DSN will also direct the upcoming James Webb Space Telescope. As the Voyagers are receding away from the Sun, their power levels are dropping, and it is becoming more and more difficult to issue and receive commands from them. However, as long as they will remain functional, NASA will continue to upgrade and enlarge the antennae of its deep space network, to continue to explore the wonders of the universe with them.